I'm just going to go through the answers to these questions from the lesson. So question 1, figure 1 shows the current potential different graphs for wire A, B and C. Using figure 1, how can you tell the temperature of each wire is constant? So because the temperature is constant, they give a straight line. If the temperature wasn't constant, it would be curved. So straight line, or constant gradient you could put. And it says which wire A, B or C has the greatest resistance? Well, the greatest resistance is the one that has the least current for the same potential difference. So that's going to be C. Okay, so it has the lowest current. Then this question says a student measured the resistance of 4 wires. Okay, the table shows the resistance and some information about all of them. And it says the last column of the table should include the unit of resistance. What is the unit of resistance? So we want ohms or ohms, like so. And it says the resistance of the wire depends on many factors. Look at the table. Which 2 wires from J, K, L and M show the resistance of the wire depends on the length of wire? So we're only looking at the length of wire. So all the other variables have to be the same. So we know it's going to have to be one of these 3 because they're all copper. And we need the other variable, the diameter, to be the same. So it's going to be K and L, and yes, their lengths are different. So it's K and L because all the other variables are kept constant. The student looked at the data in the table and wrote this conclusion. The resistance of the wire depends on the type of material from which the wire is made. The student could not be certain that her conclusion is true for all types of metal. Suggest what extra data is needed for the student to be more certain that the conclusion is correct. Well, she only tested 2 types of wire, so you should say here she should test at least 6 types of wire. Now we've got here a diagram. It shows complete figure 2 by drawing a voltmeter in the correct position in the circuit. So you want to measure the potential difference across the wire, so the voltmeter goes in parallel there. It says in the circuit diagram a wire can be represented by the symbol for resistor. What is the symbol for resistor? It's a box like that with 2 wires coming out. Next, the current in the circuit depends on the potential difference provided by the cells and the total resistance of the circuit. Then it gives you a graph and it says name the components. So the graph where the component looks like an S shape is a filament bulb. Here we've got a circuit. It's a parallel circuit. And it says, what is the potential difference across X? Well, in a parallel circuit, the potential difference is the same across every branch. That's 6 volts, because that's the same as the power supply. And it says calculate the resistance of X. Well, resistance is potential difference over current. So potential difference is 6 and the current is 3. So that's 2 ohms. What is the current in Y? Well, we've got 3 amps coming into this junction and 2 go this way, so that must mean that 1 amp goes this way because they add together to make 3. This is calculate the resistance of wire. Well, resistance is potential difference over current, which is 6 again because they get the same, over 1, which is 6 ohms. Okay. What would happen to the potential difference? It says then when the temperature of the resistor increases, resistance increases. So if we increase resistance, the current stays the same, goes down, but the potential difference stays constant because the same amount of energy is still coming from the power supply. The potential difference stays the same, but the currents will both decrease because resistance has increased. Then it says, a student investigated how current varies with potential difference for 2 different lamps. Complete a circuit diagram that the student could use to obtain these results. So you need a power supply and a variable resistor to change the potential difference. You need an ammeter